Hi, my name is Mark Hastings and I'm an application engineer at Cypress Semiconductor. During this video I will introduce you to the PSOC 3 and 5 WaveDAC 8 component and application note AN69133 that includes the WaveDAC 8 library and several demonstration projects. The WaveDAC 8 component is used to generate waveforms without CPU overhead by making use of the PSOC 3 and 5 powerful DMA feature. The component's interface and API take care of all the waveform files and DMA setup so the user can concentrate on the application code. It can be configured for either voltage or current output and supports all ranges that the standard IDAC 8 and VDAC 8 PSOC Creator component support. One of two waveforms may be selected between with the wave selection input. This makes FSK modulation very easy. The sample clock may be generated internal or external to the component depending on the application. The graphical user interface allows the user to select from four predefined waveforms: sine, square, triangle, or sawtooth. An arbitrary waveform may also be drawn in the user interface, or a waveform may be generated during runtime. For more information on the WaveDAC 8 component and details of the examples presented in this video, see Cypress Application Note AN69133. Let me give you a brief overview of what is inside of the WaveDAC 8 component. The WaveDAC 8 consists of a VDAC 8 or IDAC 8 DAC depending on the selected range, two DMA channels, an optional internal clock, and a mux to select between the two DMA channels. The DMA channels transfer data from two different memory arrays, one for each waveform, to the DAC depending on the waveform select input. The configuration dialog and the components API take care of setting up the internal components, including the DMA, so the designer doesn't have to. The AN69133 application note goes into more detail about the WaveDAC 8 operation and sampling. 4 projects are included to provide a range of application ideas. I will briefly describe each of these projects. In this example, a single continuous sine wave is generated. Notice the wave select pin, WS, is set to logic 0 since only one waveform is used. The output, P00_V out, is just a continuous sine wave. Since the component does all the work for you, notice the code to generate the signal is only one line: WaveDAC 8_1_start. It doesn't get much simpler. This is an example of the graphical user interface to configure the WaveDAC 8 component. As mentioned before, the WaveDAC 8 supports all the voltage and current ranges that the standard PSOC Creator IDAC 8 and VDAC 8 components support. The sample clock is user selectable to be either generated internally or from a clock source external to the component. If the internal clock source is selected, the sample rate is controlled by the samples per second parameter. Two waveforms may be configured, but they will use the same sample clock. Each waveform may have a different number of samples per cycle, shape, amplitude, and offset. In this example, the output will alternate between two waveforms. One waveform has fewer samples, so it will generate a higher frequency. The yellow waveform is the V out signal, and the blue waveform is the wave select input. The waveform complete outputs, WC1 and WC2, go high for one clock when a waveform has completed one full cycle. This example uses these outputs to alternate between two waveforms. Notice the code is as simple as before and requires no CPU overhead. This is the setup for the previous example. Notice the number of samples for each of the waveforms is different. Waveform 1 will have a period of 2 milliseconds and waveform 2 will have a period of 500 microseconds. Both the period and the frequency of the waveforms are provided if the internal clock option is selected. This third example is a simple FSK encoder. It uses the output of a UART transmitter to modulate between two different sample frequency or clocks. This example uses the tones used for a 1200 baud modem, 1200 and 2200 Hz. The UART output is connected to a mux, which selects between two clock sources to generate the proper tone. Notice that the 1200 Hz tone is generated when the UART output is high, and a 2200 Hz tone is generated when the UART output is low. Note again how simple the firmware is to generate this semi-complicated waveform. This example modulates the output message "Hello World" over and over. The final example is a DTMF dual-tone multi-frequency encoder. This is used by the phone company when you dial your old wired phone. Since two simultaneous tones are required, two WaveDAC 8s are used in this example, one for the column tone and another for the row tone. The scope screen shot shows both the time and frequency domain of a sequence of numbers 1, 5, 9, and D. These numbers exercise all 8 of the row and column tones of the DTMF encoder. This example is a good excuse to use the cool FFT function on many common scopes. The red trace on the scope shows the frequency spectrum of the signal. You can easily see each of the individual row and column tones. This example is a bit more complicated, but requires only about a page and a half of C code. I don't expect you to read the tiny code here, but was put here to give you a perspective of the actual code size. All four of these projects and details of their operation are provided in the Cypress application note AN69133. The WaveDAC 8 component is one of the most fun PSOC creator components to experiment with, and you don't have to write hundreds of lines of code to get results. Thanks for taking the time to watch this video, and I hope you will take the time to play with this fun PSOC creator component.